Hello and welcome back to the lab. Today on the bench we have another Tektronix bit of TM500 series, a DM504A. Now this one is an H serial number, so we actually have it in coming out of the Netherlands. This particular DMM has been sitting in the back shelves for quite some time, and its owner has been patiently waiting for its return, and it's about time we got it back to them. He sent this in a batch of TM equipment that we went through the channel, a lot of it we've already gone through. He sent a couple scopes to get calibrated. He sent actually the scope cal plugins to get calibrated. He wanted to reference them against my 7.5 digit multimeter. And he sent a couple other TM series pieces of equipment for me to get working for his own lab. This one's been sitting here waiting, and it's about time I got something going and got this one done. Now, why has this been sitting here waiting? Well, on the other DMMs that you've seen me do on the channel, they are analog devices. So they essentially use analog circuitry to do their measurements with varying degrees of accuracy that increase as they get newer. This is a microprocessor unit, processor being right there. So this unit has firmware, this unit has processing, this unit has a lot of stuff that an analog unit doesn't. It also has a very, very picky alignment and calibration routine. So if this is out, it's taken me this long to acquire the sources that I need to do an alignment on this particular meter. It's also, because it's microprocessor controlled, it's not an alignment you can do in stages. It's all or nothing. So you either have to do all of it or you do none of it. And that's what's been causing me a little bit of grief on this meter. To get this particular DMM up and running, do the alignment, it's going to take a good portion of the lab to get this up and going. Because not only do I have to do AC DC voltage, I also have to do AC DC current. That was a tricky one to come up with. My resistance box, as you've seen in a previous video, that went out, so we're going to use the new resistance box to do it. For AC and DC current, we have a Valhalla Scientific, specifically for the AC current and the high current DC. We have a source measure unit, which is going to do some of the lower current DC. I have a Fluke 1000 volt DC power supply, and I have a Fluke 5200A AC voltage supply. We are going to need to push into service the Fluke 5205, the wideband amplifier. So I'm going to pull back from this, and I'm going to show you just kind of all this gear that we're going to have to apply to get this thing aligned. And unfortunately, my lens isn't even wide enough on the camera. You guys are bumping up a desk that's back behind the camera, bumping up against the main computer desk here in the lab. And we have the source measure unit up here, resistance box here, coming down. We have this alignment and calibration stack here. There's the 7.5 digit meter, DC supply, AC amplifier. That'll do 1500 volts. That does up to 100. And that unit controls that unit through an interconnecting cable. If you don't have the interconnecting cable, there's a port on the front of this where you can still use the amplifier, but it's really nice to put the amplifier in remote control. Also, incredibly spicy voltages come out of this amplifier. 3000 volts peak to peak, 1500 volts RMS, and actually rough math, 3000 volts peak to peak, and up to I believe it's like 1 kilohertz or 10 kilohertz, something like that, but it can go all the way down to 10 hertz. So when this stuff's turned on and powered up, one, it generates a ton of heat. The bottom one's not even on yet. Got to be careful when hooking this stuff up. It's quite spicy. Underneath the bench, air line, that's where the fume extractor for the soldering iron sits. Other side of the bench, the Valhalla Scientific, that's the AC/DC current source, up to 10 amps. So I have to do up to, I think, I don't know if this is 3, no, 2 amps. Okay, so this one isn't going to be too bad. It's the AC current up to 2 amps that gets a little fun to generate in the lab, because I need this, because the AC calibrator from the other side has to feed into this. It'll be 2 volts for this particular one. So it's a 10 volt. It is a 10 volt input. So whatever voltage is put on these 2 pins, current comes out on these 2 pins, depending on what these switches are set to. So we'll set it to the 10 amp range, which is its highest range. We'll put 2 volts on that input. If I put 2 volts DC, I'll get 2 volts DC of current out of here, or not 2 volts, 2 amps of current out of here. If I put 2 volts AC at a given frequency here, as long as I'm within the bandwidth of the unit, I'll get 2 amps AC out of here at whatever frequency. So that's one of the exotic pieces of gear to align this meter. So the rebuild on this meter is actually pretty straightforward. Got a couple capacitors that the owner would like replaced, and that's about it. So the rebuild's going to take me like 10 minutes, 15 minutes. The alignment is going to take me a while, because you have to do every single range. And on the DC side, you actually have to do every single range, positive and negative. So the alignment steps on this particular meter it's not complicated. Once you have all the sources, it's not complicated. Getting some of the sources can be quite complicated. But incredibly time-consuming, because there's, I think, 50-ish alignment points that need to be done up through the meter. And basically what the meter's doing with the alignment is, when you calibrate the meter, it's you're basically putting in a known source, and you're telling the microprocessor, this is what it is. It's storing an offset, and that's how it makes measurements. This is also when we shifted focus from alignments to calibrations. Those 2 terms are thrown around quite a bit, and there's actually a very distinct difference on those 2 terms. And if you not understanding that, you might send something out for calibration and be surprised when it comes back no better than you sent it out. I did a video on this about the 7510 coming back from calibration. I actually need to send it out again just to get it checked. I don't expect there to be any problems with it. But what ends up happening is, when you send a device out for calibration, that's not calibration, alignment, and repair. That's just calibration. All they're going to do is check all the ranges, check all the functions. As long as it meets the spec sheet, it is now, quote, calibrated, and they send it back, which essentially says the device meets spec, everything's good. It could get kickback failed, where it's broken and needs to be repaired, which is one of the reasons why we have the Cal Lab here in the lab, is due to doing some of the scopes and some of the older pieces of equipment. I could send it out for calibration, or I used to be able to. Tech has decided to stop doing some of the alignments and calibrations that we can do here. But they wouldn't fix anything. So it's not, you send it out for calibration, you give them your $800. That is what some 7000 series stuff costs to get calibrated. For instance, each plugin's $899 and the frame's $899. So to do this 7603, you got $899 times 4 to get a fully calibrated unit. So it can get quite expensive quite quickly. But they don't repair it. They literally try to calibrate it. If it works, great, you get it back a calibrated unit. If you don't, you get a fail report, and that's it. And they don't give you your $800 back. Being able to oscillate between repair and calibrate until you get a functioning unit can be quite helpful, but you need specific sources to do that. So yeah, when I send the 7510 out to get aligned and calibrated, well, I don't send it out to get aligned, I get it sent out to be calibrated. It goes, they check it, it says, yep, everything's within tolerance and spec, and they send it back with a report that says this is what it actually measured. So the nice thing is, as you get those reports, you can kind of watch how the unit's drifting back and forth, because as this stuff ages, it will move around a little bit. Some of the Keithley gear and some HP gear, especially some of the HP gear we've worked on in previous videos, these function generators and stuff like this that are behind me, they have some incredibly tight tolerances, so dialing those in can be a job. But this is where we're shifting from adjustment and into calibration. So a lot of the, and you can tell this by the calibration documentation. So on the older stuff, you'll have adjustment points adjust to this, and every time you send it out, it got tuned up a little bit. When we shift to verification versus alignment, you start getting tables with limits in the service documentation. So you'll have low limit, high limit, what it was actually measured. And that's it. That's a calibration. As long as it's within those two, it's in spec, everything's good to go. Move on to the next setting, which is this guy is going to have a lot of. So I'm going to get these caps pulled out. It looks like we have 5 of them. And we will see if there's any more hiding underneath. I don't think so. We ought to be good to go. All right. After poking around and looking at getting some more information about this thing, there's something we need to check before we dive into this too far. So let's fire it up and do some comparisons, and hopefully our DC range isn't off too much, because if our AC range is off and our DC range is off, there are some capacitors we have to look at that might be a bit problematic. Okay, so we have 9.99 volts coming out of the calibrator. I'm going to hit this, let it do its thing. So that's reading way off and climbing, so I have a sneaking suspicion I know what's going on. So let's pull this cap and check it for leakage. Okay, with the covers pulled off, this is our capacitor that we are interested in taking a look at. It's a trimmer cap, and it's rated for 750 volts, but it needs to see 1,000. So most of the front end, well, these two caps right here, the red one and the glass trimmer, do see the entire voltage applied to the front end. So this one right here tends to be the sore spot. So we're going to pull him out, check him for leakage. If that is leaking, we'll have to see what the customer wants to do. Okay, so even with a glass dielectric and a trimmer capacitor, we're having less than a nanoamp of leakage across it, so that's not terrible. Not really sure how the nanoamp is leaking. Right around 1 nanoamp is leaking through glass, but definitely better than what I saw on known fault ones. The ones that I saw that were known faulted out were testing around 40 to 60 nanoamps of leakage at far less voltage. So this cap is going to be okay. We're going to get that put back into circuit and let it have a proper warm-up and see what it tells us. Okay, we have the soldering portion of the repair done. A full complement of new capacitors that needed it. We have these 33 microfarads by the ADC. And we'll talk a little bit more about these here in a bit. New power supply caps, including the 47 microfarad by 16. I did have to order some caps. I didn't have any 33s by 50, and I didn't have a 47 by 16, I think. Yeah, 4700 microfarad by 16. So the reason for those is everything I had 4700 microfarad was snap. So given that we were ordering, I was going to go back in with some 57 mics here, but since we were ordering, ended up picking up some 33s, and so everything is good there. Let's talk about these the 33 microfarad caps are critical to the function of the circuit, especially the analog to digital converter. And mine do not test well. Okay, so keeping in mind these are 33 microfarad by 40 volt. Well, that's not good. ESR has gone high and capacitance has gone low, so this one's starting to dry up. Let's check the other one. See what it says. Not great, but better. Marginally might be passable. Still not worth sending back. Here's one of the 10 mic by 25. Let's see how bad this one is. These usually don't live very well. No, that one's a little high in the ESR, but not terrible. Another one of the 10 mics. A little high in the ESR, but capacitance-wise tests okay. Let's check one of the 330s by 25. That one's starting to go a little high, not too awful. That was not too awful either, but worth checking and replacing. This is what a new, good 56 microfarad tests at for comparison. 0.1 and a little high in capacitance, not too bad. Here's the other brand new 56. Yeah, 0.1. So, starting to show their age and needing to be refreshed. Unfortunately for this repair, but fortunate for this unit's owner, if these two capacitors end up getting replaced because they are in the ADC and they're part of the measurement circuit, a complete recalibration of this unit is necessary. So what I got to do now is I got to get the shields on. We'll see how well it measures now that we've got good components in it, knowing that these two caps were starting to fail. See how it measures and go from there. We do have all the test equipment here in the lab to get this thing all squared away. So that will be next on the list. Okay, here we are ready for a power up, and let's see what ultimately happens. So we got 71.5 volts from random power supply over that way on some test leads. At least so says my DM502, which is repaired and in calibration. So this looks all good and healthy. Let's pop this voltage in. 71.2 with no warm-up, so I can't complain there. It's off a little bit, which we knew it would be, so calibration is necessary. Also, the differences between the two meters, the DM502 and the 504, are in completely, they're comparable, but they're in different classes. This has an additional digit of accuracy. So I'm going to let this sit here and burn in. As long as nothing happens and nothing goes completely sideways or crazy, we will be into alignment. Not sure if I'm going to have time to do the alignment tonight, as it is getting a bit late in the lab, and the alignment gear takes forever to warm up. So, next up for this thing, it gets hooked up to the fancy gear. Okay, this is one of those where now we have to make a judgment call, and I'm going to talk to the owner after this video posts and see what he would like to do. If he'd like me to reset the calibration constants and go through a calibration procedure, maybe that's what we end up doing. However, I have the appropriate cal gear warmed up, and we're going to run it through some tests here real quick to see what's going on, because at 10 volts, everything looks pretty spot on. I can't ask for more than that. on a DMM, and that agrees very much with my 7605. This is within tolerance for the particular meter, and I haven't let this warm up quite yet, so I got to let this warm up and go from there. So the cal gear's warmed up and on, and has been running for its warm-up period. Meter's been on for about 10 minutes. So let's let this drift down, and we'll just keep a bit busy in the lab while the DMM warms up and go from there. Okay, we're back after some warm-up, and I've got the AC source hooked up, feeding in 19 volts from the AC source as confirmed on the 7510. And that's within specification of the meter, so everything looks good there. We'll give it a little more. Actually, we'll give it a little less. 1.9 volts. Yep, that's going to be fine. And 190 millivolts. 190 millivolts. So, looking really, really good on the AC ranges. We'll turn off the AC meter, kick it over to DC. Kick it over to DC, and we will turn some meter on. And I've got negative 10 volts, and I do because I hooked up the leads backwards, so that's reading very well. Negative and positive actually read the same way. Just flip the leads around. There we go. Positive. Ding. Let's go to 100. So this is going to be 100 volts. Again, looking very good. Now we're going to get a bit spicy, and we're going to go to 900 volts. Can't complain there, and definitely, where's the finger? Do not want to touch anything on here. This is getting into elevated voltages, but that happens when you do meter calibrations. You do need to feed in extremely high voltage signals. Let's check some ohms real quick. We'll get out, we'll just get out the decade box. Make sure the meter's saying it's good and the voltage source is turned off. Not that I get blasted moving stuff around. And there we go. Kick this over to ohms. And 0.54, that's not necessarily a problem on this decade box. We know this decade box from the cal paperwork is a 0.9 or a 0.39 offset, so this is totally fine. But flip this over so it looks right. Dial a resistance. Yep, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll do 100. That looks fine. How's 1K look? That looks quite fine. 10K. Looks all right. 100K. Very good. Give it a megohm. That looks fun. We'll give it 10 megohm. See if it can. Can it? It should be able. Nope. It up. Spoke too soon. Not unhappy with that. That's 10 megohm on the DMM. Not unhappy with that at all. Also, don't want to necessarily move. Give it at up in the tens of megohms, leakage currents start to be a little wild. So, just waving my hands in front of here can mess with readings and stuff like that. So, because we're starting to get in the world of counting electrons, and we have electrons falling off the wire, which gets kind of wild. Let me start up the SMU, and we will see how this does on current. All right, we've given the SMU some warm-up time, and we'll hit this with 100 microamps. I've got a 10-volt compliance voltage, but we're going to shoot it with 100 microamps DC. See how we do. It looks pretty good to me. We have a burden voltage on this meter of about 100 millivolts, at least at 100 microamps. Not too bad. We'll see what happens when we turn it up. Let's go to 10 milliamps. That looks good. And I can dial an amperage, so I can even do 10 or 10.1 milliamp. Yep. Everything's looking good. We'll go to 50 milliamps. Yep. Just playing around with the SMU a little bit. It looks like our current resistor is about 1.5 ohm. So if we bump this up to 100 milliamp, we'll see the voltage goes up, 1.56, 1.59. Ohm's law holds. And down at the bottom, 100 milliamp. Okay, let's punch it a little bit, and we will give it an amp. Oh, isn't that fun? At an amp, I did hear a relay click, so it probably changed the current sense resistor in the unit, which is why we have a different resistance reading. This one's 0.6 ohms versus 0.15, or yeah, 0.15. But we have 100 milliamps of current. Everything is looking good. If I remember correctly, this thing tops out at 2 amps. Oh no, 1 amp. So 1.5. 1.05 is as high as it's allowed to go. So I'm pushing the SMU about as far as it can. And everything really looks good. Okay, time to do the exotic one that was causing me some problems. To get this measurement, we have the Valhalla Scientific 2500 on the 1 milliamp range. We have the Fluke 5200A outputting 10 volts at 100 hertz into the Valhalla Scientific. And the Valhalla Scientific is going to generate, theoretically, 1 milliamp of AC current. This one gets a little wild. So we're going to take that to operate, and we have 1 milliamp of AC. So the meter is doing incredibly well. We'll turn this off. We'll check 10 milliamps. I'm happy with that. 100 milliamps. Not going to complain there. And let's check 1 amp. This is an amp of AC current. Yeah, not going to complain there at all. Everything is good to go. Given that we've tested the ranges and things like that, this meter is measuring quite well and is ready to go back into service. And I can get this back to its owner. I'm going to talk to them, and at the moment I'm going to advise not to mess with the calibration. It validated very, very well, and I don't think we can improve it much more. So in this case, I think it would my personal opinion is that it would be better to let calibration constants stay constant, and to not enter cal mode and blow out the EEPROM. Again, not my unit, so that's totally up to the customer. We'll see what they say. But for right now, I think this one's good to go and ready to head back to its home. If you like what you saw, hit the subscribe, like, and comment. I read all the comments in all the videos, and everyone can find me in the comments section in between videos. If you'd like it a little bit more and want us to help support the lab, take a look at the Patreon page. Patrons are running on early access, and are running quite a few videos ahead. Currently, nothing is behind the paywall, and everything will eventually make itself up to YouTube. So, to those that do support the lab, I'm eternally grateful, and thank you so much for your support. You guys help keep the lights on here, and videos coming. With that, I will see everybody in the next video, and bye for now. More is always on the way.